Doom Coin. Have you ever wondered how many drops of water can fit on a penny? Find out for yourself. Defy gravity and show you some magic by performing the coin and water experiment. We added an extra dimension to this classic lightning-fast science experiment by comparing how many drops of water fit onto each coin and tracking the data on a free printable table. We started this coin and water experiment by placing one of each coin on a paper towel and observe which coin we thought would hold the greatest number of drops of water. We printed out the chart, available for free below, so we could keep track on our results, armed with a pencil to write with a plastic pipe and a cup of water. We are ready to begin.
The supplies and materials needed are coins in various sizes, such as 1 peso, 5 peso, and 10 peso coin. Then water dropper, then water in a cup. And lastly, pen and paper to record your findings. And here are the directions in order to do the activity. Number 1, fill up the cup of water. 2, set up coin in a completely flat surface. 3, fill out the chart with the predictions of how many drops will fit on each coin. Think about different variation and reasons for why the number of drops is what it is. 4, begin by putting 1 drop at the same time on the penny. 5, add 1 more drop at a time and keep track how many it will hold until it all falls off. 6, as you add more, notice how the water drops create a mound and hold on the other molecules. 7, do this 3 times and find the average number of drops of a penny can hold. 8, try with the other coin. As here in 1 peso coin, we just put random numbers since we don't know how many drops of water a peso coin can hold. Actual drops for number 1. The same process.
In this experiment, we are going to find out how many drops of water a 5 peso coin can hold. And we are going to try it 3 times and get their average. In my first attempt, as what you can see, the 5 peso coin can hold 22 drops of water. And in my second try, it increases into 26 drops of water. And in my last try, it only fit 21 drops. And it have the average of 23 drops. As drops of water are added onto a penny, the adhesive force between the water and the penny keeps the water from falling off. The drop of water stick together. It is also because water molecules are attracted to one another. As what you observe, there is no constant amount of droplets a coin can hold. It is because as a water drop builds up and out, usually bulging over the sides of the penny, the cohesive forces will eventually be overcome by the force of gravity on the water molecules. The skin will burst and all of the water will spill off.
So in this video, I am going to show you of how many drops of water the 10 peso coin hold. So I am writing my drops prediction here since I don't have any idea of what really is in actual. So in that random numbers, I added it out and divided it by 3. So the average is 30. So now I am performing the activity to know what is the actual drops in the first trial. So I have 30 in the first trial, and now I'm performing the second trial. So in the second trial, I have 32 drops. So clean it. So lastly, the third trial. We only have 28 drops. So we have 30 and 32 and last is 28. So divide it by 3. So we have the average of 30.
Now that you know about the Doomcoin experiment, were you surprised to discover that a lot more drops of water fit on a penny than you predicted? Here's what science explains behind this. There are two different properties working on this experiment: cohesion and surface tension. Cohesion is the stickiness of like molecules to one another, and surface tension is the result of all the water molecules sticking together. Once the water has reached the edge of the penny, a dome shape begins to form as a result of the water molecules clinging to each other until the surface tension is not strong enough to counter the gravitational pull on the water. Back on our experiment, we have here the result from the 1 peso coin, the 5 peso coin, and the 10 peso coin. And as you can observe, they have different sizes, and they also have a different degree. So the surface tension of each liquid is different, and the number of drops we can put on a coin without spilling is also different. Therefore, in this experiment, first we conclude that surface tension and cohesion is the reason why we can get so many drops of water on a penny. And second, we conclude that pennies do not hold the same amount of water due to the different viscosity and the specific gravity of the fluid, as well as the size and shape of the coin from which it is poured. So that was the end of our Doomcoin activity. Hope you learned something!